This is your video on solving equations with variables on one side, not to be confused with a two-step equation. These equations have expressions on the same side of the variable that are not completely simplified. So if you take a look at this first one, we have two x terms and we have one constant. So you need to have one x term and one constant only, no more than that. Otherwise it's not completely simplified. So we'll take a look at how to handle that. The second one we'll look at is where we have parentheses. We have 3 times the binomial 3x minus 6. So it's 3 times this entire thing, not just the 3x, but also the negative 6 there. Once we completely simplify the left side, we can then finish out the remaining two-step equation. Sometimes it might even be a one-step equation, depending on what kind of problem you have. So let's take a look at this one first. So for A, like I said, we have more than one x term. So we can take care of that by, at least one method that'll help us get the right answer is boxing and circling in the different like terms and using a t-chart to keep those the type of terms separate from the other. So first of all, we have a negative x here. So we can go ahead and put in a -1 there. Just makes it a little bit easier sometimes to work with. So we have a -1x. And I'll put a box around the type with the x. Those are the x terms or the variable terms. And I always box in the sign with the term. It helps you when you're adding or subtracting them to get the right answer. And then I'm going to circle that positive 11 because that is a constant. And so I want to keep those two types separate. I have the x terms or the variable terms and the constant. So now that I've got them separated and I know what the signs are, I'm going to go off to the side and do a little bit of work. And this is just some side work, so usually I'll put a little squiggly line just to separate my work and keep everything organized. So in the x column, I'm going to put my -1x and then my positive 10x, and I always put the signs so I can remember what I'm working with. And then for my constant column, I have a positive 11. If I had any more constants, I would put them with the -11, or sorry, the positive 11. So now I have -1 plus 10, which is a positive 9. So we have 9x. My positive 11 is the only constant that I have, so I'm just going to bring that down. And so my completely simplified version of that expression is 9x plus 11. So I'm going to bring that back over here now. 9x plus 11 equals 29. So the t-chart helped me make that equation more simple and easier to work with. So now I can go ahead and work with the remaining two-step equation. I want to get my 9x by itself, isolate it, and so that way I can just divide by 9 and I'm done. So my first step, positive 11, I need to do the opposite to get rid of that and isolate my 9x. So that's subtract 11. But remember, the subtraction property of equality tells me I have to do that to both sides. Otherwise I'm changing this equation, and we don't want to do that. And so we have 9x equals, when the 11s subtract out, add or subtract out, and then over here we have 29 minus 11, which is 18. And like I said, now we have 9 times x. I want to undo that with some division, so I'm going to divide by 9 on both sides. Those 9's divide out, and we have x, or 1x, equals 18 divided by 9 is 2. So there's my answer. Now I have to make sure that that answer really does make my equation true. And so I'm going to copy down my original equation, -1x plus 11 plus 10x equals 29. And remember, I have to use the original equation so that my check catches any mistake that I might make even up here in this first step. So my answer was 2. So I'm going to have -1 times 2 plus 11 plus 10 times 2, and then equals 29. And if we did our job correctly, once we do the correct order of operations, we'll see that the left side also gives us 29 when we put our answer of 2 in. So this is going to be, first of all, multiplication or division left to right. So we have -2 plus 11 plus, you could do this now because we are working left to right. It's not going to affect how you know the answer that you get. But also, You could also just write this down and do it in a second step. So maybe I'll do that just so you can see what I mean. And then working left to right, here's my next step. Plus 20 equals 29. I like to underline each order of operation that I'm doing. Makes it really clear. And then now addition and subtraction left to right. So negative 2 plus 11, we have 9. And then our last step shows us that we do get 29. So it made our equation true. 29 really does equal 29. The next problem is a little different. We do have to distribute first, and then once we distribute, we will have this expression on the left side completely simplified. So something that helps you get the answer right, remember, identify your signs. This is a positive 3, positive 3x, and that's a negative 6 technically. So when you multiply, you have to take that into account. So I like to do this middle step where I have 3 times 3x plus 3 times negative 6. Bring down your equals 18. And this is just me showing that I'm actually multiplying the 3 times the 3x and the 3 times the negative 6. So 3 times 3x is 9x. 3 times negative 6, this is a positive 3, is going to be a negative 18. And just like before with the problem up above, we're back to another two-step equation. So, again, I want to isolate this 9x. So to do that, I need to take care of that negative 18. Well, the opposite of subtracting 18 is adding 18. So those are going to go away. Negative 18 plus 18, that's 0. And 9x plus 0 is just 9x. And the next thing we have 18 plus 18. So that's going to give us 36. And finally, I can finish this out by dividing by 9 on both sides. Remember those properties of equality. If I do something to one side, add, subtract, multiply, or divide, I have to do it to the other side too. And then 36 divided by 9 is going to be 4. So we have our answer. And now we have to check and make sure that it makes the equation true. So I'm going to again copy down my original equation. And I have to put my 4 in where I see my x. And then again, we're going to use the order of operations in the correct way, the right order. And you'll see that this will make the equation true also. So to do that, I should get an 18 after I do the correct order of operations. So let's see what happens. Okay, so first I need to focus on inside the parentheses. But as you can see, I have 3 times 4 and minus 6. So if that happens, just follow the order of operations the correct way inside those parentheses. So the first thing I would do would be multiply, and I'm going to leave those parentheses there until I turn this whole expression into one single number. And so this is going to be 12 minus 6 equals 18. Now I'm going to finish out what's inside the parentheses. So we have 12 minus 6. 12 minus 6 is 6. So what I have here, this is 3 times this quantity. So what I have here now, because 12 minus 6 is 6, I have 3 times just 6. And now 3 times 6, finally, I can finish it out. And it does make our equation true.